Welcome to multiple choice question 17 of the 2008 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I just want to point out that the use of a CAS calculator is by far the most efficient way to answer this question, although if you hang around at the end of the video, I'll also show you how to approach this by hand. For question 17, we have the graph of the function f of x equals e to the 2x minus 2 intersects the graph of g of x, which is g of x equals e to the power of x, where x is one of the following values. So if we're looking for the point of intersection between two graphs, what we really want to do is we want to solve f of x is equal to g of x. So in terms of their rules, we just want e to the power of 2x minus 2 to equal e to the power of x. And that's something our calculator can solve quite quickly for us. On the CAS calculator, go into the main menu. Next, we want to just type in the equation that we've just written out. So I'm going to go keyboard, and then we're going to have e to the power of 2x minus 2 is equal to e to the power of x. Then we can highlight that and go interactive equation inequality solve for x. So from the calculator, we found that x is equal to ln, which is log e of 2. So that means that B is the correct option for this question. So from the examiner's report, we can see that this question was done really quite well in the exam, with 89% of students getting this question correct. Now, as I said at the start of the video, I'm also going to show you how you could approach this particular problem by hand if you wanted to, as it's the sort of question that could come up in a tech-free exam. So we start once again with our original equation where f of x equals g of x. So that was e to the 2x minus 2 equals e to the power of x. And then we just want to get this equal to 0. So we can subtract across the e to the power of x. So we'd have e to the power of 2x minus e to the power of x minus 2 equals 0. So we can look at this equation and see that it does have a quadratic structure because we've got an e to the power of 2x, an e to the power of just x, and a constant. So we can reveal that quadratic structure a little bit better by just letting, say, capital A equal e to the power of x. So therefore, we get a squared minus a minus 2 equals 0. So we can now factorize this with a subtract 2 bracket a plus 1 equals 0. So therefore, we find that a minus 2 could equal 0, or we could have a plus 1 equals 0. So finally, if we just leave a's in there for one more step, we get a equals 2 or a equals negative 1 as the possible options that we need to work through. Now we knew that a was equal to e to the power of x, so therefore we know that e to the power of x could equal 2 or e to the power of x could equal negative 1. Now e to the power of x is never equal to negative 1, so there's no solution for that half of the problem. However, we can rearrange this into a log expression to find x by itself. So e to the power of x equals 2. If we rearrange that, we get x by itself, and that's going to equal log of base e of 2. So that is the same answer as what the calculator gave, and that is the x value of the point of intersection between these two graphs. So that's how we could have tackled that question by hand if we were required to.